Hi, I'm Ming, and welcome to Kitchen Matters. Picture this. It's Valentine's Day, and you have a great idea. What better way to celebrate than to make some chocolate-covered strawberries for your friends? You have the ingredients all ready to go. You start melting the chocolate on the stove until... disaster. Instead of the chocolate becoming all smooth and dippable, it's become this grainy mess. What happened, and how do we fix it? This phenomenon we just witnessed, where the melted chocolate became grainy, is called seizing. In this video, we'll talk about why chocolate seizes and how you can rescue seized chocolate to make your own Valentine's treats. To understand seizing, let's first review the composition of chocolate. The primary ingredient of chocolate is cocoa butter, which gives solid chocolate its smooth texture. Dispersed throughout the cocoa butter are the ingredients that give chocolate its flavor, mainly cocoa solids and sugar. From this point on, I'll draw the cocoa butter as individual molecules, but keep in mind that they form a continuous solid. An important property of these ingredients is how well they dissolve in water, and this is key to why chocolate seizes. Cocoa butter is a type of fat which has low solubility in water. We say that cocoa butter is hydrophobic because the molecules dislike mixing with water. In contrast, sugar is hydrophilic because it does mix with water. As we all know, when we mix water and sugar, the sugar dissolves, but if I add a hydrophobic fat such as oil or butter, the fat stays a separate layer and doesn't mix. As you can see, hydrophobic and hydrophilic substances generally don't mix well with each other. So, if cocoa butter is hydrophobic and sugar is hydrophilic, what holds them together in chocolate? Well, there's actually a fourth key ingredient I haven't mentioned yet called an emulsifier. An emulsifier is a molecule that contains both hydrophilic and hydrophobic parts. The hydrophilic parts of the emulsifier point towards the sugar molecules, and the hydrophobic parts point towards the cocoa butter. This keeps the entire chocolate structure stable and allows the sugar to stay mixed in among the cocoa butter. We can see the effect of emulsifiers in our demo. A common emulsifier in our kitchen is dish soap, whose molecules also contain both hydrophobic and hydrophilic parts. When I add dish soap to my oil and water mixture and then stir, the hydrophobic and hydrophilic components can finally mix. In chocolate, this emulsifier is most often a chemical called lecithin, and it too keeps the cocoa butter and sugars mixed together. Now that we understand the structure of chocolate, let's turn to the process of melting chocolate. As we heat up the chocolate, the cocoa butter molecules start moving around more and more until the chocolate becomes a flowy liquid. In perfectly smooth melted chocolate, the sugars and solids continue to stay evenly dispersed throughout the cocoa butter, and that's largely because of the emulsifier helping to hold everything together. However, if we accidentally introduce water to the melting chocolate, it will stop being so smooth and glossy. Because the sugar molecules are so hydrophilic, they'll be highly attracted to the water, even more strongly than they're attracted to the emulsifier. As a result, the sugar molecules begin clustering around the water, forming clumps. This is the heart of seizing. These sugar clumps are the grainy solids we see in seized chocolate. Now, this is similar to how if you leave icing sugar out in a humid room, the sugar will also naturally clump together. If water droplets from the humid air land in the icing sugar, the sugar molecules will cluster around the water, just like they did in the seized chocolate. So we understand now that seized chocolate is caused by water, which aggregates the sugar molecules into grainy chunks. Now, how can we prevent this from happening? The first approach is to prevent water from even entering the chocolate in the first place. Make sure that any bowls and utensils you use are completely dry. Also, if you're melting the chocolate over a stove, make sure you do this uncovered. Otherwise, covering the chocolate will trap all the moisture in the air and potentially introduce water to the bowl. Now, those are all approaches to prevent seizing in the first place, but what can you do to rescue chocolate if it does seize? Oddly enough, the solution is to add more fluid. Adding water, either by itself or in liquids such as cream, can help to smoothen the chocolate back out again. As you add more liquids to the seized chocolate, there will be more and more water molecules available to dissolve the sugar, and as a result, those sugar molecules won't need to all clump together anymore. Now, you might be thinking, something feels off. Sure, we've managed to dissolve the sugar, but how does all this extra water affect the cocoa butter? Recall from earlier when I mixed oil and water, the hydrophobic oil didn't mix and formed a separate layer. Yet here, when we add water to our seized chocolate, why don't we see a similar layer of the cocoa butter separating out? The reason the cocoa butter stays mixed in with the other ingredients is because of our emulsifier, lecithin, and you're going to help me figure out how. Which of these diagrams correctly represents the structure of the melted chocolate after I add water? The correct answer is C. The lecithin shields the hydrophobic cocoa butter molecules from the surrounding water, allowing the cocoa butter to stay evenly mixed in. The answer isn't A, because the hydrophilic sugar would actually be dissolved in the water. And the answer isn't B, because the orientation of the emulsifier molecules is incorrect. Notice that structure C is kind of like the opposite of where we started. At the beginning, when the chocolate first seized, the emulsifier molecules were keeping the water and sugar mixed in with the surrounding fat. After we added more liquid, we spread the sugar out, but we also introduced more water than the emulsifier molecules could contain. As a result, now the emulsifier molecules are keeping the fat mixed in with the surrounding water and sugar. As we discussed, the orientation of the emulsifier molecules is also flipped. Previously, the hydrophilic part of the emulsifier pointed inwards towards the sugar, and now the hydrophilic part is pointing outwards. So, in summary, the way to prevent chocolate from seizing is to keep water out of the system. And in the event the chocolate does seize, embrace water as an ingredient rather than an impurity, and just add more liquid. Add a bit of liquid a tablespoon at a time, and keep heating and stirring until the chocolate is smooth again. Although this approach can help to rescue seized chocolate, the one downside is that it will involve thinning out your chocolate mixture into a runnier sauce. But if you're careful, this can still be a good consistency in which to dip our strawberries. And there you have it. We've managed to rescue our seized chocolate and make a bunch of Valentine's treats. Come, let's bring them to campus and deliver them to my friends.